Well, welcome. I'm JJ. Let's do an example problem. In this one, we have some lamp here is supported by cables A and B. Cable A, we know, can support a maximum load of 150 pounds. So let's write that as TA max. TA max is 150 pounds. If it goes over that, the cable is going to break. And cable B can support a maximum of 100 pounds. So we could write that as TB max equals 100 pounds. Let's determine the maximum weight of our lamp, which could be supported before one of these two cables breaks. So this is what's called a demand capacity problem. Demand capacity problem. Demand capacity problem. Basically, we're saying what's the most this could be before one of these two cables breaks. Odds are they're not going to break at the exact same time. One of them is going to hit this maximum value first. So if we're doing a problem like this, we need to make an assumption. There's a demand capacity problem. We're going to say let's assume either TA is at max, or that TB is at max, or TB is at max. But the one thing we're not going to do on here, we'll say but not both. But not both at max. One of these or the other will hit the maximum value first. Not both of them at the exact same time. So we need to make a guess in here. Realistically is what we're doing. Right now, if we don't know TA, TB, or the weight, that's three unknowns. I have two equilibrium equations. We couldn't solve this out. I'm going to assume that either TA hits max or TB hits its max value. One of the two of those must be true for us. That forces one of them to a known value. We can then solve for the weight, solve for the other tension in our cable. So we want to make an assumption and go for it. To do this, though, we're laying out equilibrium equations. If I'm using an equilibrium equation, I really should have a free body diagram that goes with it. So I have everything passes through my ring in the center here. Let's draw a free body diagram of this point. So we'll circle around. I cut through three cables. The three of those will show up in my free body diagram. So let's come down below and get that drawn in. That's the particle we're working with. Going straight down, I should have the weight of the lamp. Going horizontal, I have the tension in cable B, TB. And going up and to the left, I have the tension in cable A, TA. And my angle in here is a 25-degree angle. So we can get that labeled as well, 25 degrees. Again, it looks like three unknowns. I'm going to assume one of these is at that max value, though. As I do that, I'm making an assumption here. I need to check my assumption. So let's add that in. Must check the assumption. Must check our assumption. So let's come in and just try this. So I can either assume TA is 150 or TB is 100. It really doesn't matter for us. Let's start and just 50-50 it. I'm going to assume TA equals TA max. Assume. So my first step in here, assume TA equals TA max, which equals 150 pounds. So I'm setting this variable to 150. I can solve for TB then, and I'll compare it to TB max to decide was this the right assumption or not. I can do that by just summing forces in the x. Summing forces in the x direction. I have TB entirely to the right minus the x component of TA, or minus TA I assumed was 150 times the cosine of my angle, cosine 25. For an equilibrium equation, I need to get that equals 0 in there, and then I can solve this out. TB is my only unknown. I'm going to get that TB is equal to 136 pounds. So for TA to get to 150, TB would have to be supporting 136 pounds. Can that happen for us, though? It can't. The maximum it can support is 100 pounds. So we're going to say this is greater than TB max. Therefore, this is a bad assumption. Therefore, bad assumption. Which isn't really a problem for us. It just means I should have guessed the other one. So start over. 2. Let's assume that TB equals TB max, which is 100 pounds. As I do that, I can then come in and solve for TA. So summing forces in the X again, I would have TB is entirely in the positive direction. I am assuming it's 100 minus the X component of TA minus TA cosine 25 gets me to 0. Solving for TA, I'm going to get that TA is equal to 110 pounds. 110 pounds. Comparing that up to my maximum value, again, we're saying if TB is at 100 pounds, TA is only at 110 pounds. That's less than the max value it can support, which means this is a valid assumption. It's okay for us to move forward with this. This is less than TA max. Therefore, our 3 dots, this is a good assumption. Good assumption. Once I have that good assumption, I can move forward. So my third step for this is just find W. I can do that by summing forces in the Y direction. I have one unused equilibrium equation. Let's tackle that. Summing my forces in the Y. I'm going to have, well, TA acts up, so it's going to be positive. We know TA, though, is 110. So 110 sine 25 minus the weight equals 0. Which, solving for the weight, we'll get our final answer out here. W is equal to 46.6 pounds, which is our final answer. If we are at 46.6 or below, TB will be at its maximum value. TA could still support a little bit more, but that doesn't really matter because TB would be about to break. We have to be there or less as we go in there. Again, if these videos are useful for you, hit the like and subscribe buttons. Otherwise, sorry, but stick around, tune in. Let's get you an A with JJ. Take care.